So yesterday you were verifying differential equations. Today we're going to look at some differential equations. Just so you know, there are multiple classes in college called differential equations that have different types of differential equations in them. So this is a huge, big topic. One of the reasons why we had that big question on one of the questions and why this works and that doesn't work. But what a differential equation is, it's an x and y is an equation that involves x and y and the derivatives of y. So we've solved two different types, y prime equals f of x and y double prime equals f of x. So we've already taken the derivatives. That's where we get our differential equations. So now we'll learn to solve a more general type of differential equation called variables separable differential equations. So like when I tell you there's all kinds of different ones, we're only looking at one little variation, which is variables separable. We can separate them. There are people that are doing their doctorates on non-separable ones and other types, like that are still trying to figure all this stuff out. So it can get crazy, crazy. These aren't going to get super crazy. The strategy used to solve these is to rewrite the equation. So each variable occurs on only one side of the equation. It is important that you actually write this stuff down. Some of you are still struggling with actually writing stuff down because of some bad habits that you were trained with coming up. It's not necessarily your fault, but like you have to write it down. And I think sometimes we get to the point where you think, oh, I don't know what to do, but you're thinking 3 steps ahead. You've got to write down piece by piece more than you may want to write down, and it'll be okay, I promise. All right, so this looks a little wacky here, but it's really, I mean, it's explaining to you what to do, so it looks weird, but it's not that bad. So if it's a differential equation that is in this form, or can be put in this form, where we have dy dx equals, see all these have a dy dx equals, and then we have some x's and y's on the right-hand side, we want to figure out if it's separable. They're not all separable. So today we're going to focus on, can we actually separate them? And if so, you know, what is it going to look like? So here are your steps. Step 1, separate the differentials first. Meaning, if you have dy dx, whatever's in the denominator, that's what you start multiplying both sides by. So you have the y on the right, the x on the left, and whatever else is on the right, and we try and move it over. So then we separate the other variables by multiplication and division, right? The constant, if there is one, because there could be one, there's some, you know, there's a constant right here, there's going to be that -2, whatever. It can stay on either side. However, if we try to solve the differential equation, a lot of times you're trying to solve for y, it's better to keep it on the dx side. So I mean, that's kind of our goal, to keep it on the dx side. Because in the end, it's going to have to end up over there anyway. All right, does that make sense? So we're going to go through a couple of these, and then I'm going to have you work through some of these. Let's just start. Look at how simple this is. So on number 1, our first step, and you should get to a point, I don't want you to be at that point today, even if you think you are, where you don't have to write down as much, and that's okay. But right now, I want you actually writing it all. So we want to separate them, right? So we only have y's on the left and x's on the right, or vice versa. So I'm going to multiply, see, I wasn't even touching. There's going to be extra marks everywhere. Multiply both sides by dx. So this is going to give me dy equals -2y times dx. Everybody with me on where all that came from? Okay. So then I'm going to leave the dx on the right, the -2 even, I'm going to leave it on the right, and then I'm going to divide both sides by y. So that's going to give me 1 over y dy equals -2 dx. So now I have only y's on the left, only x's on the right. Okay? Putting dy over y is fine as well. I could have written it that way. If I put dy over y, do the y's cancel out? No, because dy is one thing, right? So don't make up math. So I could have written it that way. Either way is totally fine. But there are reasons why you might want, you know, these things kind of separated. Okay? We good on that? Does that make sense? All right, so you see if you can do number 2. Same thing, multiply both sides by dx. And then see if you can get it with just the y's on the left, just the x's on the right. And remember, you don't want to get dinged by a misuse of equality. So think about the work that you're writing down too. Some of the work that you don't think is important because you know what you're doing, and I agree that you know what you're doing. Let's think about what it's going to look like. So if I multiply both sides, I'm going to get dy equals, see my equal signs are going to look like z's for a while because, yeah, so y equals, like I have to really put my pen up. I'll get used to it. Equals negative 2y plus 3, and then I need parentheses dx. That's what I was talking about there. If you just have negative 2y, so I'm going to write this down, then I'm going to erase it. But if you put negative 2y plus 3 times dx, that's not really what you mean, is it? You have to be careful when you have more than one term that you have the parentheses there, okay? Because then when you move on, even if you do things correctly, what you're saying it was before doesn't jive with what you just did, okay? So now I have dy on the left. I have all of this over here. So I can just divide by this, right? So I get 1 over negative 2y plus 3 times dy equals dx. Or I could have dy over that. Either way is fine. What did you do? I got a huh? Okay. Okay. I took out the y. Oh, I see what you're saying. Yeah, so okay, here I probably should have shown my work, but here I divided both sides by y. That's what I did. And that's where I got 1 over y, and then those just canceled out there. Okay, so let's talk about what you did and why it doesn't work, because I'm pretty sure you're probably not the only one. I'm going to erase it. So we had dy equals negative 2y plus 3 times dx. He did a beautiful job with his parentheses. Then he distributed. So we got dy equals negative 2y dx plus 3 dx. Okay, everybody with me so far? Okay, so then what did you do next? Divided by y. Tell me why that doesn't work. Because you only divided this one. If you're going to do that, you have to do every single term, which then just puts a y over there, which you don't want. And it doesn't just cancel out that way. Does that make sense? Common mistake, but that's why that didn't work. All right, any questions on that? Y'all good on that? How to get there? Okay, so in this case, we didn't leave the constant on the right, and that's okay, because it didn't say you had to. It said if you can, and then we just move on from there. Which question? Right, so even here, is this the negative 2 that's confusing you there? Okay, so a correct answer could have been 1 over negative 2y dy equals dx. That's not wrong for this one. It's just that if we can leave it, we leave it. If you didn't, that's fine, because when we then go forward to do other things, we would take care of it. But basically, we don't move it if we don't have to, because we're going to have to end up putting it back. Okay, you with me on that? Okay, no, that's fine. So this, yeah, write down whatever you need to write down. So this would be an okay answer. Are we okay with that? It's just that I chose to leave that behind because of what it said, and it was okay. Right? Good question. Anything else? Okay, so then I want you to do number 3. And remember, don't make up math to force things. Okay, so everything you've done so far is legal? Do you have only y's on the left and only x's on the right? It's like you haven't done anything wrong. I'm just asking if you're finished. That's all I was asking. haven't made up math, so that's good, number 1 there. So that, where did we go before? You were here. And then, so then what you did is you multiplied both sides by 3x, but this is being added. So that wouldn't work because it's one denominator. Can you? Is there anything you can factor? Okay, so let's look at what we got. dy is one thing, exactly. All right, so let's see what we got here. We got dy equals -2, see? Practice, it'll get better with practice. -2y plus 3x. The only way I'm going to get better is if I practice, so I got to use it, times dx. Okay, so that's what happens in my first step. I multiply both sides by dx, right? So if I divide both sides by this, that's fine. That's where I saw a few people do that. So like if I have dy over -2y plus 3x equals dx, this is not wrong. I haven't done anything wrong. But I have an x over here where I wanted only y's on one side, only x on the other side, right? So then there's no way really for me to move this x out of the denominator, okay? So I'm kind of stuck there, right? So I'm thinking, okay, so I didn't want to go down that road. Now, if I distribute this, so if I say dy is equal to -2y dx plus 3x dx, okay, which is what I saw also, so that's a good thing to try, right? So then the only way for me to move this term is to add it, right? So then I would get dy plus 2y dx equals 3x dx. That's a dx. Now, I can't factor out a d. That doesn't work, right? There's no way for me to get this dx out of there. You see that? So this is one because it says right here, if they are separable, the answer to this one is not separable. Okay, not separable. Do you understand why? Okay. And until you really get an idea, like you'll get pretty good at looking at them and going, okay, I think I can separate this one, or no, this one doesn't. But sometimes you're going to think the answer is no when it's not no. The other thing is, actually separating them before we do anything is a super big problem. It's super big problem. It's super important because that is kind of what starts you off getting the points on the questions. Usually 5 points for this is what I've been told. And so the whole separating thing, that's your first point. But if you don't do it, if you skip over it because you see other things in it, then you lose all 5 points. And we don't want that to happen. Okay? So I'm going to let you work through the rest of these together. And we'll get to a point where maybe I'll work through some of these. We'll see what we're disagreeing about, but work through them. I'll check what you got. All right, so let's look at 4. So my first thing I'm going to do is multiply both sides by dx. So I'm going to get dy equals -2 dx. I don't have any other variables, so that's good, right? That one was pretty straightforward here. All right, so then let's look at number 5. So dy is equal to 3x squared times y times dx. So good job putting the parentheses there. There's absolutely nothing wrong with it. But do I have to have them in this situation? I don't, because it's all, if you do, it's fine, and there's nothing wrong, and they don't hurt anything, and it's all fine and good. Here I have to have them because I have more than one term, and here. But here that's all one term, so I'm totally fine. Okay? Not separable was a pretty popular answer. But my goal is to get all the y's on the left, all the x's on the right. In this particular situation, that's not always my goal because variables can change. But how can I legally move this y? I can divide by y. So I can have 1 over y, or dy over y, it's fine. dy equals 3x squared dx. I even could have divided by 3y and still been legal, but I want to leave the x's over there, but I also want to leave the 3 on the x side if I can. Okay, we good on that? Questions? All right, so let's look at number 6. here I've got dy equals 3x squared plus y. Do I need parentheses here? Yes, here they're required, times dx. Okay, so when I think about my next step, well, if I divide both sides by this, I end up in this pretty much in this exact same situation right here. You agree with that? If I distribute, then I end up pretty much in the exact same situation I am here, right? So is this separable? No. And if you actually wrote it out, that's fine. I'm just not going to take the time to do it because you can't really read what I'm doing anyway. So this is not separable. We're good on that? Okay. So I wanted to pause here because so many people on 5 were saying not separable, but it is. So keep going here. All right, so on 7, I'm going to get dy equals y times secant squared x dx. Okay, parentheses not necessary, but fine if they're there. Then I'm going to divide both sides by what? Y. So I'll get 1 over y dy equals secant squared x dx, and then we're good to go. Yes? All right. Here, I'm going to multiply both sides by dx, so I get dy equals kx. Kx dx. Talk to me about k. What's k? A constant. Okay, so it's just like if it was 3x dx, right? So do I need to move anything? Nope, we're good to go. All right. So then this one, I'm going to get dy equals the sine of x cosine squared x dx. What do I do next? Nothing. I'm done, right? All the x's on the right, the y's on the left. Okay, good. All right, you work on 10, 11, and 12. All right, so 10, we start with whatever the denominator is, right? So dp equals k times p dt. Love that t. Am I done? No, what do I do next? Divide by p. So 1 over p dp equals k dt. Are we all okay with that? Yes? Okie dokie. So then, here, I got dy equals x plus y times dx. All right. So if I distribute, then I'm going to be in the same issue I was on that first one, right? If I just divide, I have that other same issue. So if we look back at 3, 6, and 11, all 3 of these are very similar to each other, right? So what do you think the answer is to 11? Not separable. Good. Uh-huh. Yes.
Okay, so whenever we get a question similar to this,
Mm-hmm.
do I have to write out where I got stuck?
No. Because we will do this, so that's a very good question. So his question is, do I have to show where I got stuck if it's not? The answer is no. You will get to a point, hopefully, where you can look at it and you kind of know if it is or it isn't, but you need to be careful with that because it's not always about an addition and subtraction because 12 is separable. But no, you can just put not separable. Very good question. All right, so let's look at this. We'll multiply both sides by dx. So dy equals e to the x plus 2y times dx, right? Okay. So yes, I have an addition, which I did on 3, 6, and 11, which ended up being not separable, but this is in the exponent and they have different rules. So can I split this? Like, what's the rule? Like, when do we add our exponents? When we multiply the bases, right? So if I have x squared times x cubed, it becomes x to the 5th because I add 3 plus 2, right? So this can become, dy equals e to the x times e to the 2y times dx. Do you see how that's the same thing? Because if I was to make this back into the 1, all I do is add the exponents. So now that I have this, is there another step I can do? I can divide by this guy, right? So this will give me 1 over e to the 2y dy equals e to the x dx. Now I have my y's on the left, the x's on the right, okay? dy over e to the 2y, yes, that's fine. Everybody good with all that? So I will tell you, that there's no more that are not separable. So separate them. I'll give you a minute to work on that and think on that. I said there's not any more that aren't separable. So the last 3, they are separable. So figure out how to separate them. Okay, so here's the first thing that I've seen. So I saw dy equals, and then xy minus y times dx. Okay, so all that's great. Then quite a few of you distributed. Am I right about that? So we got dy, and again, if you didn't do this, don't mark yours or anything. So I have x times y times dx, x times y times dx minus y times dx. Okay. Then you divided everything by y, so we ended up with 1 over y equals x dx minus dx. Okay, a lot of you ended up there, right? Which isn't wrong. Oh, I forgot the dy right here. dy. Which isn't wrong, but we can only have 1 dx, so we have to factor this out. So we have 1 over y dy equals x minus 1 times dx. Okay? So that works. We didn't need to necessarily distribute on all these. My suggestion to you would be probably don't distribute. I mean, because I knew on these, like 3 and 6, you were doing that because, like, what else can I do to kind of distribute? Instead, Jeremiah had a very good question, which was, do I have to start by multiplying? And you don't, but whether you end up here or you did it first, when I'm here, my goal is to move y, right? So I can see in these two, I have a y in common. So instead, I'm going to jump here, kind of skip all this stuff, and I can have dy equals, I can factor out this y times x minus 1 times dx. See, I just factored out my GCF there? Then, once I have it factored out, then I can divide by y, and I get 1 over y dy equals x minus 1 dx, and it saved me a bunch of steps, okay? So my suggestion would be let's try and not distribute. Now, on 14, any questions on 13? Even if you did it a little different, but you got this, then you were okay, but trying to factor out a GCF is going to make it a little quicker. So when we look at 14, so dy is in the denominator, but I'm still going to multiply by the denominator. I'm not going to try and get the x's on the right, y's on the left, because it really doesn't matter which side as long as they're separated, as long as they're opposite. So I'm going to have dx equals y minus 1 times x plus 2 times dy. No reason to FOIL, no reason to distribute. My goal is, since I have dx on the left, dy on the right, all the x's on the left, so I can divide by this. And I can have dx over x plus 2, or 1 over x plus 2 times dx. I was just doing it different because you know that it can be either way. These parentheses I still need, y minus 1 times dy. Okay. Any questions on any of those? All right. Let's look at 15. So I'm going to multiply both sides by dy. So dx equals, I have x over y plus 4 over y. So there's addition there, but that doesn't necessarily mean it's not separable. Multiply by dy. Do I have a GCF in my parentheses? Yes. What is it? Y. So 1 over y, yes. So dx equals 1 over y times x plus 4 times dy. Now what can I do? Divide by x plus 4. Dx over x plus 4 equals 1 over y dy, or dy over y. Any of those work. Okay. Now again, if you distributed and then did other things, that's all fine and great, but in the end, we can only have 1 dx and 1 dy on each side. Okay? You did it the long way. That's okay. That happens sometimes. You'll get better at doing it the shorter way. You'll start seeing things a little bit better. As long as we understand how to do it, we're good. Okay? Are we good on that? Any questions? Okay. So I think that we have 5 minutes left. I think we're going to stop today. Actually, well, yeah, we'll stop today so we can start back over there tomorrow. Okay. So all we did was separate them. That's it.